A mile-thick ice cap left Nova Scotia more than 9,000 years ago, but the Earth's crust is still rebounding. The center of the Earth's rebound, shown in red, is now in the Hudson Bay area, far to the northwest, causing Nova Scotia, shown in dark blue and circled in red, to currently sink at a rate of 1 foot every 100 years. Add 3 feet of sea level rise in the next 70 years, and many Nova Scotia shores will be underwater this century. The Bay of Fundy has 50-foot tides, the highest in the world, and pinkish-brown waters from the astonishing 100 billion tons of tide flow every 6 hours. Tides in each arm of the Bay of Fundy, red arrows, equals the water flow of all the world's rivers. The southern zone of Nova Scotia, called the Miguma Terrane, was once closer to Africa and South America, while the eastern half of the northern zone, called the Avalon Terrane, is similar to Scotland and Ireland. The two zones are separated by an ancient fault. The geology here is complex, with the northern zone dating back 700 million years and the southern zone 540 million years. Coastal shoreline types in Nova Scotia include sand beaches, cobble berms and cobble beaches, sloping rock benches, near vertical cliffs, often with terrestrial erosion above and marine erosion below, sedimentary bluffs and intertidal flats, marsh systems and intertidal flats, coastal rivers and bogs or heaths. We will take a closer look at each type of shoreline, beginning with sand beaches. This sand shore is flat and shallow, well out into the sea. Heavy wave action dissipates in the intertidal zone before reaching this beach and dunes. There are occasional rock formations leading out into the water, forming jetties. Further south, you see higher dunes where the sea is slightly deeper offshore. The sand here extends well inland in a complex of low dunes and wetlands. There is a foundation of rounded rocks on the beach and in the wetland behind, but sand dominates this shoreline for several miles. The dunes are protected from wind erosion by a carpet of sedges and grasses near the beach, and a thick variety of plants and shrubs inland, along with Krumholtz spruce. Ponds are located in this area, some of which may be brackish from groundwater and salt spray. A sand dune complex forms a peninsula out into a large bay. The shallow sand bottom extends a long distance out into the bay, providing protection for the dunes and limiting erosion from wave action. Behind the dry flat, which is submerged only at the highest tides, a second higher line of dunes protects a large bog and wetland. This second line of dunes is 7 to 10 feet high and has a number of spruce trees. The water here on the western shore is shallow for a long distance offshore into the bay, protecting both the sand beach and the cobble berm to the north from waves which break well out into the intertidal zone. The sand shoreline changes to a cobble berm north of this sand dune complex, with several notably large glacial erratics sitting on the beach. Cobble berms adjacent to a sand beach is an example of two coastal landform types intermixed or adjacent to each other. Together, the cobble berm and sand dune complex protect a large wetland with several lakes from flooding or wave action. With a rising sea and a sinking landmass, these berms and dunes will have to grow and adapt to continue protecting the wetland. With a projected 3 feet of sea level rise in the next 70 years, they may not adapt fast enough. Here are 8 examples of cobble berms and cobble beaches in Nova Scotia, showing their diversity and unique characteristics. We will explore several of these in more detail. Notice the shallow water and large stones offshore. Heavy wave action or storms break far offshore, sparing the shallow Cobble berm except for storms on the highest tide. It is useful to remember shallow offshore, shallow Cobble berms onshore. The seaweed-covered rock zone may look devoid of life, but it is a thriving environment. Laminaria, commonly known as kelp, species dominate. When you have more rock offshore, you often find sand on the beach in a more protected environment, as seen here. Large cobbles on this beach at Bacquareau Point attest to the wave action that has moved smaller cobbles elsewhere. The shallow water offshore in the intertidal zone has protected this surprisingly exposed point until now. This point is unlikely to exist at the end of this century, and a new point will be further inland due to sea level rise. The rocky bottoms, shoals, and shorelines of many bays in southern and southeastern Nova Scotia protect wetlands and bogs inboard of their berms. They reflect thousands of years of wave action, building different-sized rock in berms and beaches from glacial outwash, while sea levels have risen due to glacial melt, then fallen as Nova Scotia has rebounded from the weight of glaciers. It is surprising that the sea builds the rocky berms higher where they are the least protected. Walking along these beaches, one can see the berm is lower when it is protected by a rocky shore and rocky shallows, or shallow water offshore. The Cobble berm is lower because most wave action occurs well offshore, and the berm is impacted by waves only on the highest tides. Conversely, where wave action has access to the berm due to deeper water close to shore, the berm is higher and wider with larger cobbles to withstand the tumult. The low berm at Bacquareau Point protects a wetland for now, but will be underwater later this century. Look at the number and size of trees stacked on top of the gravel berm at the 5-mile-long Advocate Bay beach, brought here by very strong currents flowing along this beach on tides of 30 to 41 feet. The incoming tide at Cap d'Or flows clockwise in Advocacy Bay and counterclockwise in Greville Bay, meeting offshore of Cap d'Or in a frightening tumult over a submerged basalt reef. This incoming tide flows east through the Minas Channel, leading to Minas Basin, the easterly arm of Bay of Fundy, where current flows in the Cape Split entrance reach an astonishing 16 feet per second. This flow in 6 hours refills the Minas Basin, an area up to 25 miles wide and 50 miles long, up to a depth of 50 feet, the highest tide in the world. A look at the beach and tall protective berm shows smaller gravel than the cobble we expect, because it is built from glacial outwash deposits. Looking southeast, we see the end of this 5-mile beach at the vertical cliffs of Cap d'Or. Here we see examples of sloping rock shores and vertical cliffs. We will explore several of these sites in more detail. Gaff Point, facing England on the east coast of Nova Scotia, near Lunenburg, is exposed to the full force of the Atlantic Ocean. The rock shore is inclined and forms both the shoreline and sea bottom out some distance. Some inclined rock layers are harder than others, leading to variable erosion over thousands of years. Gaff Point is in the Maguma supergroup, igneous beds laid down in the depths of an ancient ocean closer to Africa. We see the spruce-covered Gaff Point on an unusually calm day for Nova Scotia and take a 360-degree look, first to the north, then around through the west, south, and east, viewing the calm Atlantic on this sunny day, then back to north. The island offshore of the point is West Ironbound Island. Looking north, we can see the miles-long beach at Hartling Bay. Some large groups of older spruce on the Gaff Point Peninsula appear dead or have extensive damage. A close look at Gaff Point shows the bog or heath capping the point, wrapping around to the eastern side. In addition to sedges and grasses, there is a dense carpet of shrubs growing on the bog, under a growing cover of young spruce trees, extending over much of the Gaff Point Peninsula. The lighthouse at Cop Door sits at the southern end of dramatic vertical cliffs formed of North Mountain basalt, with 100-foot cliffs on the southern side, overlooking the meeting of treacherous tidal currents just offshore in the Minas Channel, and 600-foot cliffs on the western side. We see these cliffs at slack tide. The Mi'kmaq people mined copper here for 2,000 years. Samuel de Champlain rediscovered the copper in the early 1600s on one of his many trips across the Atlantic. Located just south of the fault dividing Nova Scotia, the cliffs here are the same North Mountain basalt as that forming the thin mountain range on Nova Scotia's mainland to the east across the bay. Nova Scotia's west coast, from Cape Split down to Briar Island, is called the North Mountain Ridge. North Mountain basalt is an igneous rock that is often columnar in shape and can be seen along these cliffs. The basalt layer is believed to have flowed and formed during the opening of the Atlantic Ocean and is 200 million years old. That's 100 million years before the dinosaurs. A number of rock falls from the cliffs are seen along the beach, not yet dispersed by strong currents and heavy waves of the bay. Rock and soil erosion take place at the top of the cliffs, and strong currents and wave action erode the base of the cliffs. For the cliffs to remain vertical, these forces must be in balance. The full force of the currents flowing out of Advocate Bay flow along these cliffs and collide over an offshore basalt reef with the extreme eddy current flowing south out of Greville Bay to our east. Fortunately, we are here on a calm day at slack tide, when one could walk on this beach for a short amount of time, but rockfalls from above are a constant danger. As we climb up over the cliffs and turn to the east, we can picture this lens of North Mountain basalt extending under the Minas arm of the Bay of Fundy and forming the western coast of the Nova Scotia's main peninsula we see to the east, from Cape Split down to Briar Island. The Apple River flows into the Bay of Fundy in a shallow bay, showing a similar reddish-brown color present in Bay of Fundy tides. This flat bottom occupies much of the bay and can be explored at low tides. This coast has sedimentary rock bluffs, among the oldest parts of North America. The geologic history here is immense. Cliffs along this western Bay of Fundy shore have fossils dating to the earliest forms of life. South of Apple River is Cape Chignecto, where the highlands end in 600-foot cliffs dropping into the sea, similar to the cliffs at Cop Door. A tip of Chignecto was part of Gondwana, which later separated into South America and Africa. Then about 220 million years ago, during the late Triassic period, the supercontinent Pangaea began to break apart. The focus of the rifting began somewhere between where present-day eastern North America and northwestern Africa were joined. The southern end of Nova Scotia was cut and formed by glaciers, and later by the retreating ice cap. Many of the long promontories and islands cut and formed by glaciers were composed of glacial till and drumlins, but along the Tuscat River, an extensive silt loam supply allowed tidal marsh development. Silt deposits formed around islands in the Tuscat Delta, creating a large salt marsh on Surratt's Island and similar salt marshes on nearby islands. These salt marshes and some buildings are flooded multiple times annually, causing recent construction of a new access bridge and the raising of Surratt's Road several feet using gravel fill. Dominant species here in the salt marshes are American cordgrass and salt marsh hay. Species like bladderwort and the rare curly grass fern are also present. The classic river at Port Latour is bounded by grass and sedge meadows for more than a mile. The river meanders between the east edge of a large raised bog and higher mounds of glacial till populated by spruce trees. The Latour River bisects and also drains a large forested area on the Baccaro Point Peninsula that has been heavily cut and now looks like a young forest. Leaving the river at Port Latour, we fly over the edge of a large raised bog, part of the Port Latour wilderness, the yellow area you see on this map. The wilderness and surrounding lands contain many bogs. Many southern Nova Scotia peninsulas were formed by glacial scouring and are underlain with glacial till and contain extensive wetlands and bogs. Many bogs, like this one, are raised. Rare Canadian threadleaf sundew is known in only 5 locations in Canada. 4 of those 5 locations are here in this 2,500-acre wilderness. The nearby beach at Port Latour supports a rare breeding site for nesting piping plovers. The Port Latour wilderness and the nearby beach area are both important high-use migratory bird protected areas. Nova Scotia has an extreme geologic history. It has fossils of earliest life, and it was formed from 3 very different parts of the Earth's crust 480 to 200 million years ago.